I wanted to cover factoring a difference of squares. One, because I don't have a video on this yet. So I was looking through the topics and I'm like, what do I not have video on? So this is something I don't have a video on yet. Second, this shows up a lot, and recognizing the pattern of a difference of squares can really save you time when you do factoring. And so we're learning factoring this week, and you're going to be factoring every single week after this. It comes up every single week in the class. You're going to be doing some factoring. So it's really important, and any trick that you can learn to save you time is great. So difference of squares is one of the most common shortcuts that we see. And so it's really important to recognize this so you can just factor it within seconds, and it will save you a lot of time. And then difference of squares is basically all about finding a pattern and recognizing a pattern, and practicing that pattern recognition is one of those things that's really important for problem solving that I talked about last week, the different tricks for problem solving, and a lot of it is recognizing patterns. And so the difference of squares is a particular type of pattern that you look for, and then when you see that pattern, you just know this is what I do to factor it. So to start off, just to give you some basics, what is factoring? When we say factoring, what does that mean? Factoring is actually a process where you take a polynomial and then you break it up into multiplication. So a polynomial is just a whole bunch of things added together. And there are polynomial, you can't have any variables in the denominator. There are no negative exponents. There's no fraction exponents, but mostly everything you see in algebra is a polynomial. So I have an example of a polynomial here, x squared minus 19x plus 88. So that's a polynomial. You just have a series of things added and subtracted, basically. So they're split up with addition and subtraction. And factoring is taking something that looks like that and then turning it into multiplication. So we have two things multiplied here. X minus 8 times x minus 11. So you're just taking something and turning it into multiplication. And factoring is used a lot because we use it for solving. We use it for simplifying really complicated fractions that include variables. Yeah, those are the two basic things, but you do that a lot. So factoring really does show up a lot. And so that's what it is. We're just kind of putting it in a different form. And you can even factor numbers. Like if you were looking, instead of things with variables, if you just ignore letters and all that stuff, like if you have the number 36, factoring that could turn it into instead like 9 times 4. So it's the same thing. They're equivalent. It's just another way of writing the number. And for numbers, there's multiple ways to factor it. So you can do 9 times 4 for 36. We could do 6 times 6. We could do 1 times 36. 3 times 12. There's lots of ways to factor that number. With variables, there's only one way to factor it. So that's going to be nice because there's only one possible way that you can do it. You might write it in a different order, like I could put the 11 part first, but there's only one combination of multiplication pieces. So factoring is something with letters, with variables, is almost better because there's one answer versus if you're trying to factor a number, there's lots of possibilities. So that's basically what factoring is. And we're going to look at just a specific pattern of polynomial because there's a shortcut to it. So the pattern we're looking at is a difference of squares, and it is literally what the name says. We have a difference, which is subtraction. So you're subtracting two things, and they are things that are squared. So you're just subtracting two squares. That's a difference of squares. So in the box here is the formula. So if you have something like a squared minus b squared, you can rewrite that as a minus b times a plus b. And so you have this pattern and you recognize what you have on the left. So your steps are first is to recognize you have a difference of squares, which means, okay, it's in this form. I can use this formula. Step 2 is determine what are a and b. What are those things that we have squared? Or what a squared and b squared, basically, I should say here, a squared, b squared, and then determine what a and b were before they were squared. And then you basically build the factors by doing, you basically create the right side. So it's a lot of recognizing patterns here, and then you're just filling it into the form, and then you're done. So I have many examples, so that way you can see all the possible ways that these could look like, and you have an idea of what to do. So these two examples are the most basic form that you will see. So these say factor the binomials, and a binomial just means we have two terms. So we have two things separated by a minus here. You could also have binomials that are separated by a plus, but you basically have two terms. That's just what we call something with that's a binomial. Bi just means two, like a bicycle has two wheels. So that's what that word means. In ALEKS, there's that dictionary. So if you see the word, you can look it up in the dictionary if you're not sure, and then you can refresh. That's what a binomial is. So I have two binomials here. We're going to use the difference of squares pattern, which I'm going to rewrite a squared minus b squared. And I usually write this as a plus b times a minus b, but if you want, you could put the minus first and then the plus second. So the order of the multiplication doesn't matter because of the commutative property of multiplication. So whether you put the minus first or the plus first does not matter. What matters are the actual things you're putting on either side of those symbols. So first example on the left, we've got y squared minus 25. So when you're factoring, you're going to see a lot of things in this form where you have your variable squared minus a number. That is the most common way you're going to see these. And you're going to want to be able to see that and instantly say, aha, this is the difference of squares. And so obviously you look at the y squared and you're like, yes, that is something squared. But 25 is not squared. But 25 can be rewritten as something squared. So 25, oops, not equal. 25 is the same as 5 squared, because 5 times 5 gives you 25. So when you're looking at these, you're looking for what number I could rewrite the number as, and it's going to be something squared. So knowing your multiplication tables is really good, because then you know 5 times 5 is 25. Also knowing common square roots. So in week 1, we did some order of operations, and you're taking square roots of number. And so understanding that the square root of 25 is 5 squared can help you, because the number that's squared, the square root basically undoes the square. So if you look at this and you're like, I can take the square root of 25 on my calculator and get a whole number, taking that square root will give you your value that's squared, because they undo each other. So we have y squared minus 25, which we can rewrite as y squared minus 5 squared. And so now we're in the form, in the pattern for the difference of squares. Because to use the difference of squares, you have a squared minus b squared. Something squared minus something squared. And we have that here. We have the y squared. So the first thing is y. And then the second thing here is 5. So I have something squared minus something squared. And that's the way I kind of think of it, is I don't look at this a and the b. I just think of something squared minus something squared. So like we can kind of do boxes here. And so you're just looking for the pattern and you're filling in your boxes. Actually, let me color these in and then I will color code. So the first thing is orange, and that always goes in the front. So if you color code, you can kind of see the pattern. And then let's say the second thing is blue, and that goes in the back. So if you don't like to see it with variables, you can look at it as colors to kind of see the pattern here. So we have y squared minus 5 squared. The y is basically the orange, the 5 is the blue. So to factor this, let me go back to my green. So we've got y, I'm actually going to put it right underneath so you can see the pattern. We have y squared minus 5 squared. So if you follow the pattern, that is y minus 5, close your parenthesis, times, so another parenthesis, y plus 5. And then this on the right is your answer. So you're going to want to kind of see that pattern, and all you need to do is recognize that it's in the pattern, and then you need to be able to pick out what your two pieces are. What's the orange? What's the blue? And then you just plug it in. You just replace those boxes, and that gives you your answer. Are there any questions on this first example with the y squared minus 25? Okay, so let's look at the one on the right. This is x squared minus 9. So that x squared, we already know it's something squared. And then you want to ask yourself, can I take the square root of 9? If I put that in my calculator, will I get a whole number? And the square root of 9 gives you 3. So what this tells you is that you could rewrite this as x squared minus 3 squared. And so now looking at that, you're looking at the pattern. You have x and 3 as what you're going to plug in. So I like to set up my parentheses first. And then I like to put in my plus and the minus or the plus, whichever order you want to put them. Again, that order doesn't matter. And then the x goes in the front, the 3 goes in the back, and that's your answer. So it gives us x plus 3 times x minus 3. And honestly, once you see enough of these, you don't even need to write the middle step. You can go straight to the answer. And that's why this is a good shortcut, because you can do it in your head when it's in this form. It's all about recognizing that it's in this form, seeing the pattern, and then plugging in it. Okay, so these are the easiest kind that you'll see, and these are the most common. But there are some where they get a little more complicated here. So I'm kind of ramping up the difficulty with each slide, basically. So I'm going to start by rewriting our formula again. I'm going to do it the same way I did with the color coding. And I do recommend that you do this every time you do a problem just until you learn the pattern, because math is one of those things that if you have formulas or you have shortcuts, you learn from repetition. And so writing it down lots of times can help you learn because you're repeating it over and over and over again. So that is our basic form that we're using, the pattern. So let's look at the one on the left. We've got 81 minus 64b squared. So with the numbers, we're looking for things we can take the square root of, because that is the opposite of squaring. So the square root of 81 is 9. So I can rewrite this as 9 squared. And then I'm going to have my minus. Now we have something with a number and a variable, and it works the same way. So you just take the number and you say, what is the square root of 64? And that is 8. So this would be 8 squared. And then we have b squared. So we're just writing the numbers as their exponent version so that we can see that we have things squared. Now notice that the 8 squared b squared is not exactly in our form, because in our pattern we have a single exponent of 2, and here we have 2 exponents of 2. But there's a nice little trick where this is the same thing as if you put the 8b together and then you squared it. And now it's in our form. 9 is the orange, 8b is the blue. So now we have something squared minus something squared. And so now we can put it in our pattern. And I'm going to make sure that I leave myself enough room here. So the 9 squared, 9 goes in front. And then we have 8b squared, so 8b is in the back. Okay, that is our final answer here. 9 plus 8b times 9 minus 8b. 9 plus and 9 minus 8b. So let's take a look at the second one, and I want to make this a little more interactive. So you guys can just use the chat and first tell me, how are we going to rewrite the 16? So if I want to rewrite it as something squared minus something squared, let's start with the 16. So I can even fill in my form, and I'll be filling in my parentheses. What is going to replace the 16 in this pattern? Since 16 is the same thing as 4 squared. So now what about the 49w squared? Try to follow the same pattern that we did and try to put it in the form that I have in the second step. Try to identify what we would have in the parentheses there. So what would we rewrite the 49w squared as? (7w). So let's see, we've got 7w here. So 7 squared will give us 49, so that works. And then the w squared, that gives us our w squared. So it is 7w. So 7 times 7 is 49. So I can determine that 7, and then we've got w. So now we're going to put it in our pattern. So I'm going to just set up my parentheses and set up my plus and my minus. And then the 4 goes in the front. 7w goes in the back. And then that's our answer. The hardest part out of all of these is probably just recognizing what you're squaring, but once you see it's in the form, then you figure out what you're squaring, and then it's just plug and chug. It's like you don't even have to think after that. You're just putting the numbers at the front and the back. There's no thinking involved. They just go there. It's a pattern. You're using that to speed things up. Now I do have a side note here. What if, so let's say instead of 81 minus 64b squared, it was 81 minus 65b squared. So or what if it was like 70 minus 64b squared? Or we can even do both and do 70 minus 65b squared. So what if I just change the numbers slightly? The 81, that's still 9 squared, so I can still write that as 9 squared. But we have a problem with the 65b squared. I can put a b there, but the square root is 65. So if you do that on your calculator, and I'm actually going to grab my calculator, it is giving me a decimal. So I'm getting like 8.06. I get a whole bunch of decimal numbers. It doesn't give me a whole number. So if you take a square root of the number and it doesn't give you a whole number, then it's not in this form, because we can't find something squared. We have an issue. We're getting a decimal when we take the square root of the number. And this causes a problem in the 70 minus 64b, because 70 doesn't, when you take the square root, you get a decimal. So while the 64b squared is okay, we have issues with the 70. And then when you combine those, you have an issue with the 70 and with the 65. Oops, I don't want to write 65. The 65 part. Because you don't have a number to put there, you'd have a decimal. When we factor, we don't use decimals, we want whole numbers only. So in these situations, if you can't take the square root, if there isn't a number that works, then this is not a difference of squares. Actually, let me put that over here. These are not difference of squares, because they don't have numbers that are squared. So they don't work in our pattern. And we would say that these are prime. My M did not connect. Other ways that you can factor to maybe make them a little better, but they're not a difference of squares, so we can't use this shortcut, basically. So when you're using this, you want to make sure that it does fit the pattern. Just because it has two things that are subtracted does not mean it's necessarily in this pattern. So if you can't find a way that works, if you can't find a way to put it in the pattern, then you need to try a different way of factoring. So you do want to pay attention to that, because we have to make sure the first part works in order to do the second part. Now I'm adding variables to both. So we're ramping it up. So now we've got variables on both sides of the minus. And again, I'm going to write down our pattern so that you can learn it. And then I will color code. And I recommend that you color code when you're doing your notes and stuff like this. So just so you can see the patterns. If you're following those color codings and if you're being consistent, It kind of helps things stand out. And I also recommend, there are a lot of directions that I'm giving verbally that I'm not writing down. And so what I would recommend doing, maybe after this, going through your notes and rewriting your notes, or maybe tomorrow after I email out the spreadsheet, but I would go back on all of these examples and make sure you're writing down the steps, and then you're putting the work with each step. So like step 1 would be what you're given, the thing that's of difference of squares. Step 2 would be determining what the things are squared. And step 3, what was squared. So steps 2 and 3 are like the first thing that I've written down on this example, where I rewrote it as like y squared minus 5 squared, or x squared minus 3 squared. That would be like steps 2 and 3. And then step 4, build the factors. So that would be the last step here. So if you want to go back in your notes, I'm not writing down the directions with these, I'm just showing the math. But in your notes, you're going to want to write down those directions, so that way you know what step goes with each thing. Or maybe write a note to yourself of what you did. Why did we rewrite the 9 as 3 squared? Things like that. I don't have room to write that, and I'm saying all this verbally, but in your notes, you're going to want to make sure you write those down, because that's helpful when you're on a quiz and then you have to, you're trying to follow those steps. If you have that written down, it's easier to follow on a quiz. So just adding that in. So now that I've got my pattern here, and I wrote the minus first instead of the plus, again, it doesn't matter with the pattern since it's just multiplication. So I'm going to look at the first example here, 4a squared minus 81b squared. So we want to write this as something squared minus something squared. And so it's just like what we did on the previous example, it's just now we've got variables in both. I know that I'm going to have an a and a b because I have a squared and a b squared. The question is, what are the numbers? So the square root of 4 is 2, so that's going to be a 2a. And the square root of 81 is 9, so that will be a 9b there. So you just fill it in so that you have your pattern. And then once we've determined that, I'm going to put it in the factored form. And so my 2a goes first, and then 9b goes second. So let's see what you guys can do with the 25c squared minus 36d squared. So try to factor, don't just try to do the whole problem on your own. Because one of the things about when you're learning online, especially when you're learning from videos, is sometimes you have to pause a video, attempt the problem to see if you understand what's going on, and then check if you're right by watching the rest of the video, by pushing play. It's a really good skill to test your understanding. So I'm going to work it out. So 25 is 5 squared. So we've got 5c squared minus, and then 36 is 6 squared. So I'm going to put 6d, and then that will give me 5c plus 6d times, oops, I gotta make sure I write the right numbers, 5c minus 6d. And you want to be very careful that there is no symbol in between the parentheses in the middle. So no symbol there, because this is multiplication. I've seen people, when they start to do factoring by grouping, which is another method of factoring, want to put a plus sign in between or a minus sign. I don't know why I crossed my L. We don't have a symbol. When we're doing factoring, it's just multiplication, and we don't put a symbol in there. So you don't want to put an X in between there. I've seen people do that. It will be marked wrong in Alex if you put an X. You do not want to use like a multiplication sign or anything like that. There is nothing in between the two sets of parentheses. They're just up next to each other. So just a tip there from some things that I've seen people do. So good. You're probably, hopefully you're thinking, oh, this isn't bad. This is pretty easy. So let's throw in some tricky things here for you. So these are looking like the first ones we started with, except that they're not squares. We have 4s. So there is a pattern that you can notice with variables as long as the variable is an even number. So if the variable is an even number and the number is still something you can take a square root of, it's still a difference of squares. So there's sort of a modification of our difference of squares formula. And I'm going to still write it with the squares and just write down that pattern. But there's a modification that with variables, the variable needs to be even for it to work. So the variable, or the exponent on the variable, I should say. So actually, let's see, I'll just write that in the middle. Exponent on the variable, that needs to be an even number. And then with the numbers, we need to be able to take the square root. And those are your rules. If it fits that, if your exponent on the variable is an even number and the number portion you can take the square root, that means it's a difference of squares, even if the exponent is not a 2. So there's a different way that we can write these. It's a little tricky, but once you get it, it's not so bad. So we're still looking at a difference of squares. But for the exponents on the variables, you divide it by 2. So oops, I don't know why I wrote y. Probably because I was looking at the one on the right. So we have an a to the 4th. So we write that as a squared in the parentheses, and then we have a square. And then 16 is 4 squared. So I took that exponent of 4, I divided it by 2, and that's the exponent that goes in the parentheses. And this works because a squared times a squared is a to the 4th. And if I split up the a squared is a times a. And so these are the same things. So a to the 4th is 4 a's multiplied together. And I'm just grouping them in pairs so that I have it squared. So it's just taking a rule of an exponent that we already know. We know an exponent means repeated multiplication. And instead of combining it as one single exponent, I'm sort of combining it as 2 exponents so I can use the exponent rule and make it squared. Once you go through the video on exponents, this will make more sense, but this is essentially what we're doing. We're just doing a little finagling of what we have to make it work, because it's not normally something squared. So I've done that. I'm going to color code here so I can use the pattern. So now that I've kind of shown what we've done, I'm going to put in the pattern. So I have a squared in the first set of parentheses. And then I have 4 in the second set of parentheses. Now, I want you to notice right here, a squared minus 4. This is another difference of squares because 4 is equal to 2 squared. So we can break the a squared minus 4 further. We can factor that part and get even more pieces, basically. The a squared plus 4 we can't factor. If there's a plus, it does not fit our pattern. That can't be split up. So that has to stay the same. So we have a squared plus 4, but I can split the a squared minus 4 even further. So I've got a squared, so that means there's going to be an a in front and then in the back. I've got my plus and my minus. And then 4, I can rewrite that as 2 squared. So 2 is going to be in the front and the back. So we actually end up with 3 things multiplied together because we had to use the difference of squares twice on 2 different things. Okay, so let's do this on the example on the right, the y to the 4th minus 1. So same pattern. I'm going to rewrite this as y squared and then the squared. And then 1 is the same as 1 squared because the square root of 1 is 1. So I'm going to use our pattern. I'm going to have y squared in front, 1 in back. Then I have a y squared minus 1. That is another difference of squares. So I have a y squared plus 1 that I can't factor. And then I'm right on our kind of smushing this in. Now I need to factor my y squared minus 1. So that would give me a y and a y because that's y squared. And then the square root of 1 is a 1 and a minus 1 there. And so that is our final answer for that example. So now I'm going to add in a third slide here that I didn't actually plan for, but I just thought of it as I was going through here. What if we had y to the 4th minus 9? So we saw it with a to the 4th minus 16, y to the 4th minus 1. Let's do y to the 4th minus 9. So I'm going to rewrite this as y squared for the y to the 4th. And then 9 is 3 squared. And so I'm going to use my pattern. Y squared in front, got a plus and a minus, and then a 3 in the back. Now let's take a look at the y squared minus 3 here. So our previous 2 examples, that was another difference of squares because we could take the square root of 4, and that gave us 2. And we could take the square root of 1, and that gives us 1. But in this example, the square root of 3 is a decimal that I do not have memorized. It comes out to 1.7, lots of decimal points. So here, the difference, the square root of 3 is 1.7, so that is not a difference of squares. So we can't factor it further. So if you can't go further, then you just stop where you're at, and that's your final answer. So you do have to do some consideration here and think, do I have a difference of squares here? Can I keep going? Or if not, then I stop. So we were able to keep going with these two examples, but we can't on this one. So you do have to kind of use some thinking here. Don't get too much into the pattern, because then you might try to do something that's not going to work. And you would figure out it wouldn't work, because then you'd be like, well, what do I put? And you'd be like, I don't know what number goes to 3. So a nice little what if there kind of thing to watch out for. Okay, and now these are my last 2 examples that I've planned. These are now exponents of 6. So I said that as long as the variable has an even exponent, you can still use the difference of squares, assuming that the number portions you can take square roots of. So how it works here, and actually let me try to get into good habits. Let me rewrite our formula. There we go. Okay, so we have something that has an exponent of 6. And to sort of explain what's going on here, I take the k to the 6th. So that is equal to 6 k's multiplied together, because that's a rule for an exponent is repeated multiplication. We want to write this as something squared, which means there's 2 things multiplied together. So we're going to group it up so you have 2 things. And within those 2 things, we have 3's. So it's basically k cubed times k cubed, which can be written as k cubed squared. So that's how we're going to rewrite this. So when your exponent is 6, you can split it as something cubed squared. So I mentioned you're basically dividing your exponent by 2 when you're doing the difference of squares, and that holds here as well. So if your exponent is 6 on the variable divided by 2, you're going to use a 3 inside there. So we're going to rewrite our 49 minus k to the 6th. 49 is 7 squared. And then we're going to have k cubed squared. And so now we have 2 things squared. And I can put it in my form. The 7 is going to go first, my plus or minus, and then k cubed in the back. Now we don't know any rule for factoring something 7 plus with a plus there. And we have a minus, but we cannot take the square root of 7, and we have an odd exponent on our variable. So even though we have a minus there, it's not a difference of squares. So you do have to consider that. Does it meet our qualifications for the difference of squares? And it does not. So that's as far as that particular problem can go. And we'll do the same thing here on the right with the 4 minus h to the 6th. So 4 is 2 squared. And then we're going to use the h to the 6th. We're going to rewrite as h3 or h cubed squared. And so then when we factor, the 2 goes in front, h cubed goes in the back. And again, I can't go further because we have a plus. There's no rule for that. And then with the minus, we can't take the square root of 2, and we have an odd exponent on our h, so it doesn't fit the difference of squares. All right, so to recap, oops, I'm trying to find the right slide. There we go. To check to see if you have something in the difference of squares, you need to make sure that you have the subtraction. You need to make sure that your exponents on the variables are even. And you need to make sure that you can take the square roots of any numbers that are involved in that form. If those 3 things hold, you have a difference of squares and you can use this shortcut. So I should have made a slide of that. I didn't think of it at the time, but I should have put that on the slide. How do I know I have a difference of squares? These are the 3 things to look for. So you can make your own slide that says that, or your own notes. But then once you have that, it's just a matter of putting it in the form, and it's not too bad.